Dear learners, welcome to the course Electromagnetic Fields. In this video, I am going to explain various coordinate systems. Generally, in the electromagnetic fields, different coordinate systems are available. But in this course, we are going to talk about only three important coordinate systems, such as Cartesian coordinate system, cylindrical coordinate system, and spherical coordinate system. So, in this video, I am going to explain Cartesian coordinate system. Before going to start the Cartesian coordinate system, first let us talk about what is coordinate system and what are all the applications of coordinate system. Then, what is coordinate system? Coordinate system is a system designed to establish positions with respect to given reference points. Applications of coordinate systems in daily life. First application is describing position of any object. Coordinate system can be used to find the position of any object from its original place to its present location. Another application is location of air transport. We all have seen the aeroplanes flying in the sky but might not have thought of how they actually reach the correct destination. Actually, all these air traffic is managed and regulated by using coordinate geometry. Next application is weather forecasting. In real life, when weather forecasters are tracking hurricanes, they note the absolute location on a periodic basis to see the path of the storm and try to predict the future path based partially on these findings. Another application is latitude and longitude measurement. A latitude measurement indicates locations at a given angle north or south of Earth's equator. So, latitude measurements range from 90° north at the North Pole to 0° at the equator to 90° south at the South Pole. A longitude measurement indicates locations at a given angle east or west of an imaginary north-south line called the prime meridian, which runs through Greenwich, England. Longitude measurement begins at 0° at the prime meridian and extends 180° both the west and to the east. Longitude measurement begins at 0° at the prime meridian and extends 180° both to the west and to the east. Next application is Global Positioning System, GPS. A GPS is a space-based satellite navigation system that provides location and time information in all weather conditions. In a GPS, the longitude and the latitude of a place are its coordinates. The distance formula is used to find the distance between two places in GPS. Another application is map projections. The map projections, generally we want to reach any unknown location, immediately we access the Google map, we seek the help of the Google map. So, map projection is one of the important applications of coordinate systems in our daily life. Map projection is a technique used to map any 3D curved object on a flat 2D surface. What will happen if it does not exist? Now imagine what if coordinate system does not exist. Pilots, aircraft controller, passengers in the flight, persons waiting for the flight, all will not be able to get the location or position of aircraft. These will also definitely increase the chances of aircraft crashes. So, from here, we can easily say that coordinate system is one of the most important parts of air transport. So, from this, we could understand what are the applications of coordinate system. Next, we are going to start the Cartesian coordinate system. To describe a vector accurately and to express a vector in terms of its components, it is necessary to have some reference directions. Such directions are represented in terms of various coordinate systems. There are various coordinate systems available in mathematics, out of which 3 coordinate systems are used in this course, electromagnetic fields. These are Cartesian or rectangular coordinate system, cylindrical coordinate system, spherical coordinate system. First, we are going to talk about Cartesian coordinate system. This is also called rectangular coordinate system. This system has 3 coordinate axes represented as x, y and z, which are mutually perpendicular at right angles to each other. This is also called rectangular coordinate system. This system has 3 coordinate axes represented as x, y and z, which are mutually perpendicular to each other. These 3 axes intersect at a common point called origin of the system. There are 2 types of the systems are called right-handed system and left-handed system. The figure A, it illustrates right-handed system. You just note down. The right-handed system means if x-axis is rotated towards y-axis through a smaller angle, then this rotation causes the upward movement of right-handed screw in the z-axis direction, which is shown in this figure A. So, in the left-handed system, x and y-axis are interchanged compared to right-handed system. This means the rotation of x-axis into y-axis through smaller angle causes the downward movement of right-handed screw in the z direction. So, generally, a right-handed system is very commonly used in electromagnetic fields. In Cartesian coordinate system, x equal to 0 plane indicates 2-dimensional YZ plane. Y is equal to 0 plane indicates 2-dimensional XZ plane. And Z is equal to 0 plane indicates 2-dimensional XY plane. Next, we are going to talk about how to represent a point in rectangular coordinate system. A point in rectangular coordinate system is located by 3 coordinates, namely x, y and z coordinates. The point can be reached by moving from origin. The point can be reached by moving from origin the distance x in the x direction, then the distance y in the y direction, and the distance z in the z direction. Finally, the distance z in the z direction. Consider a point P having the coordinates x, y and z. It is represented as point P, x, y, z. Let us consider the point Q, 3, minus 1, 2. This point, which is shown in this figure. Okay, we consider Q is 3, minus 1, 2. Another method to define a point is to consider 3 surfaces, namely x equal to constant, y is equal to constant and z is equal to constant planes. The common intersection point of these 3 surfaces is the point to be defined and constants indicate the coordinates of that point. So that means a point in a Cartesian coordinate system is nothing but the intersection of YZ plane, XZ plane and XY plane. For example, we consider point Q, which is intersection of 3 planes, namely x equal to 3, y is equal to minus 1 plane and z is equal to 2 plane. So, So now the intersection of the x equal to 3 plane, z equal to 2 plane and y is equal to minus 1 plane is nothing but point q 3 comma minus 1 comma 2. So this constants may be positive or negative. This is an illustration which is the example for Cartesian coordinate system. So classroom, we can easily remember the xy plane, xz plane and yz plane in the Cartesian coordinate system. We see here in our classroom yz plane where we placed y code. That plane is called as yz plane. And next, the window side is the xz plane. And the xy plane is the plane where you are lying. Okay. We are sitting on the xy plane. So from this we can easily understand the three planar surfaces in the rectangular coordinate system. Base vectors or otherwise unit vectors in Cartesian coordinate system. The base vectors or the unit vectors which are strictly oriented along the directions of the coordinate axis of the given coordinate system. So for the Cartesian coordinate system, the unit vectors are oriented in x, y and z axis. So it is represented as ax vector, ay vector and az vector are the three base vectors or unit vectors of Cartesian coordinate system. So any point on x-axis having coordinates x, 0, 0 can be represented by a vector joining origin to this point is denoted as ax vector. So the unit vectors are very important in representing a vector in terms of its component along with the three coordinate axes and position vectors and distance vectors in Cartesian coordinate system. Consider a point P, x1, y1, z1 in Cartesian coordinate system as shown in this figure. Then the position vector of point P is represented by the distance of point P from the origin directed from origin to point P. This is also called radius vector. This is represented in this figure. The position vector is directed from origin to the point P. Origin to the point P is called as a position vector. The position vector of point P can be represented as ROP vector is equal to x1 ax vector plus y1 ay vector plus z1 az vector. The magnitude of this vector in terms of three mutually perpendicular components is given by modulus of ROP vector is equal to root of x1 square plus y1 square plus z1 square. Thus, if point P has coordinates 1, 2, 3, then its position vector. That means the vector components are 1, 2 and 3. So, we can write the position vector ROP vector as 1 ax vector plus 2 ay vector plus 3 az vector. So, from this we find the magnitude of this position vector. Magnitude is root of 1 squared plus 2 squared plus 3 squared. The answer is 3.7416. Many times the position vector is denoted by the vector representing that point itself. That is, for point P, the position vector is P vector. For point Q, it is Q vector and so on. The same method is used hereafter in this course. Note the difference between point and position vector. Now, consider two points in a Cartesian coordinate system P and Q with the coordinates x1, y1, z1, x2, y2, z2 respectively. The points are illustrated in this figure. P and Q are denoted in this figure. The individual position vector of these points are P vector equal to x1 ax vector plus y1 ay vector plus z1 az vector. Q vector is equal to x2 ax vector plus y2 ay vector plus z2 az vector. Then the distance or displacement from P to Q is represented by a distance vector. PQ vector is given by PQ vector is equal to Q vector minus P vector. This is also called separation vector. PQ vector is otherwise called separation vector. It can be written as x2 minus x1 ax vector plus y2 minus y1 ay vector plus z2 minus z1 az vector. Then we find the magnitude of the distance vector. Modulus of PQ vector is equal to square root of x2 minus x1 square plus y2 minus y1 square plus z2 minus z1 square. This is nothing but the length of the vector PQ. So the distance vector which gives the distance between the 2 points representing bits of the vectors. Using the basic concept of unit vector, we can find the unit vector along the direction PQ. So unit vector A PQ vector is equal to unit vector along PQ is equal to PQ vector divided by magnitude of the PQ vector. Once the position vectors are known, then various mathematical operations can be easily performed in terms of the components of the various vectors. Right, let us summarize the procedure to obtain distance vector and unit vector. The first step, we have to identify the direction of distance vector, that is starting point and the terminating point. The second step, subtract the respective coordinates of the starting point from terminating point. These are three components of distance vector, that is x2 minus x1 ax vector, y2 minus y1 ay vector, and z2 minus z1 az vector. The third step, adding three components, distance vector can be obtained. And the step 4, calculate the magnitude of the distance vector using the equation. And step 5, unit vector along the distance vector can be obtained using equation. A vector PQ is equal to unit vector along PQ is equal to PQ vector by modulus of PQ vector. Next we are going to talk about differential elements in Cartesian coordinate system. Consider a point P x, y, z in rectangular coordinate system. Let us increase each coordinates by a differential amount. A new point will be P dash. A new point will be P dash. Obtained having the coordinates x plus dx, y plus dy, z plus dz. That means dx is a differential length in x direction, dy is the differential length in y direction, dz is the differential length in z direction. The differential vector length can also called elementary vector length, which is represented as dl vector is equal to dx ax vector plus dy ay vector plus dz az vector. The magnitude of the differential vector length is square root of dx square plus dy square plus dz square. The differential vector length is the vector joining original point P to the new point P dash. Now point P is the intersection of three planes, while point P dash is the intersection of three new planes which are slightly displaced from original 3 planes. These 6 planes together define a differential volume which is a rectangular parallelepiped as shown in this figure. The diagonal of the parallelepiped is the differential vector length. The differential volume of the rectangular parallelepiped is given by dV is equal to dx dy dz. Note that dl vector is a vector quantity but dv is a scalar. Let us define differential surface areas. The differential surface element ds vector is represented as ds vector is equal to ds an vector, where ds is the differential surface area of the element and an vector is the unit vector normal to the surface ds. Thus, various differential surface elements in Cartesian coordinate systems which are illustrated in this figure. The vector representation of these elements are ds vector, dsx vector is the differential vector surface area normal to the x direction. That is dy dz ax vector. The surface normal to y direction is dx dz ay vector. Similarly, differential vector surface normal to z direction is dx dy az vector. The differential elements play a very important role in the study of engineering electromagnetics. So now you are very clear about the Cartesian coordinate system. Thank you.